Okay, this is Larry Hatcher, Psych 100. We are still talking about intelligence. At a previous class meeting, started talking about intelligence in general, gave a definition for intelligence, talked about the Wechsler Adult Intelligence Scale, how it's divided into different subscales, and how the different subscales combine to give people an IQ score. I said some things about criticisms of IQ testing in general and the way that IQ test scores are often used in making important decisions about people's lives. I said some things about Gardner's theory of multiple intelligences, and that was where we had left off. Showed a video related to that. We posed a question that might appear on the next multiple choice quiz related to Gardner's theory of multiple intelligences. And the topic that we're up to right now is this: the effect of heredity and the environment on intelligence. That's where we're picking up today. First up, let's make a global statement. That yes, intelligence is influenced by both. Experts today agree that intelligence is influenced by heredity. It's also influenced by the environment. I'm going to go over just a few pieces of theory and research backing up this statement. Let's begin with heredity. Most experts in the area agree that intelligence is to some extent influenced by heredity, the genetic endowment that you received from your parents. We can't conduct true experiments to investigate this relationship. Strongest evidence that we have comes from correlational studies, and specifically the strongest evidence that we have comes from the studies that show there's a strong correlation between the IQ scores that are displayed by identical twins. Even when those twins are reared apart, even when those twins are raised in different environments. Anytime we're dealing with some kind of a trait that can't be manipulated experimentally in humans, we rely on correlational evidence to draw conclusions as to whether this trait is possibly influenced by genetics. When it comes to intelligence, the strongest evidence that we have that intelligence is to some extent influenced by heredity is the fact that there's a strong correlation between the IQ scores displayed by identical twins, even when those twins are reared in different environments. I'm going to show you correlation coefficients for 3 different groups of individuals. These groups are going to differ according to the extent to which they're genetically related to one another. Eventually, comparisons of the IQ scores displayed by these 3 groups are going to display the evidence we have that heredity is to some extent influenced by, that intelligence is to some extent influenced by heredity. First of all, we're going to look at our first group of participants, unrelated persons reared apart. Imagine this is kind of a thought experiment. Imagine you got the telephone book for everybody that lives in New York City. You open it to a random page, you choose somebody's name at random, that's going to be a participant. Then you open up a telephone book for Los Angeles, California. You open it up to a random page, choose somebody's name at random. You put these 2 people together, and they are your first pair of participants. Now, these people are almost certainly not related to one another genetically. They're almost certainly not related to one another in terms of the environment in which they were raised. They are your first pair. Now, you're going to create a second pair. From telephone book New York City, you draw somebody at random. From telephone book Los Angeles, you draw somebody else at random. Put those 2 people together. together, you now have your second pair. Imagine you continue this process, putting together pairs of individuals that are completely unrelated to one another genetically, completely unrelated to one another in terms of their environment, until in the end you have 500 pairs of individuals. They're middle-aged people now. You administer an intelligence test to the person from New York and administer an intelligence test to the person from Los Angeles. Do the same for each person in these 500 pairs of individuals. Now compute the Pearson correlation between their IQ scores. You'll remember from an earlier unit we learned that lowercase r is our symbol for the Pearson correlation coefficient. It's a statistic that indicates how strongly two variables are related. If you computed the correlation between the IQ scores for these individuals, you'd probably find that the correlation is 0 or close to it, meaning there's no relationship. If the person from New York had an IQ score, it wouldn't tell you anything about whether the person from Los Angeles would have a high or a low IQ score. If the person from New York had a low IQ score, it wouldn't tell you anything about the IQ of the person from Los Angeles. If people are completely unrelated genetically and unrelated in terms of their environment, we expect the correlation between their IQ scores to be 0. Now we have this first group of individuals just as kind of a baseline against which we're going to compare the other two groups of individuals. We come to group number 2. They are going to be siblings reared apart. Siblings are brothers and brothers, sisters and sisters. Imagine this. You go to adoption agencies and state agencies that are responsible for placing people that are orphans. You tell them, I want to identify pairs of siblings that were separated at birth and raised in totally different families, totally different environments. They lived their lives without knowing each other, without knowing anything about what happened to the other. Now they're middle-aged. I'm going to look these people up. Imagine you get the cooperation from agencies that give you these names. You find one person who's now middle-aged, and this person has a brother 2 years younger than him who was adopted by a different family, raised in a totally different family. You identify these two individuals, administer an IQ test to both of them. That's going to be your first pair of siblings. Now, find another sibling who was separated from, another individual was separated from a sibling at birth, raised in a family, and that person's sibling raised by a different family. Assess the IQ of both of these individuals. That's your second pair. Repeat this process until you have 500 pairs of individuals within a given pair. They are siblings raised in totally different environments. They're middle-aged. You administer an intelligence test. You determine the correlation between the IQs, and you find the correlation is a positive 0.24. Now, positive 0.24, positive means there's a relationship. If one person had a high IQ, there's some kind of probability that the other one had a high IQ as well. But a correlation of 0.24 is relatively weak correlation. Remember that correlations can be as big as 0.99 or 1.0, negative 0.99, negative 1.0. So a correlation of 0.24 is relatively weak correlation. If this was the only other group that you had to compare, and you saw there was such a weak relationship between the IQs of siblings reared apart, you'd conclude, well, maybe genetics don't have much to do with intelligence. Maybe heredity doesn't have much effect on intelligence. You would conclude that unless you came to our third and final set of individuals. These are the important individuals in our study. They are identical twins reared apart. Now, individuals like this are very difficult to come by. You go to adoption agencies and you tell them, I want you to give me the names of people who were identical twins very early in life, preferably right after birth. They were separated. One of them was raised in one family, the other one was raised in a totally different family, and they grew up without knowing each other, without being in the same environment. There's not a whole lot of people like this. University of Minnesota has conducted program research on this topic for decades. They have a long list of people who are identical twins, some of whom were raised in different environments. Let's imagine you were able to identify by 500 pairs of identical twins. They're identical twins, meaning they're genetically identical, but in this case, they were people adopted in different families, raised in different environments. They're middle-aged now. You administer intelligence test, compute the correlation between the IQs. The correlation is 0.75. That is a strong positive correlation. Correlation of 0.75 means that if one of them has an IQ of 120, there's a good chance the other one has an IQ very close to 120. If one of the twins had an IQ of 90, there's a real good chance that the other twin would have an IQ very close to 90. This is evidence that genetics appear to matter. Even though they were raised by different families, presumably in different environments, when they're middle-aged, they still have very similar IQs. That's the strongest evidence that we have that heredity makes a difference, that genetics have an effect on the intelligence displayed by people in middle age. Now, we're talking about evidence about heredity and evidence about the environment. These correlation coefficients are the kind of evidence that supports the idea that heredity matters. I haven't gotten yet to the evidence that the environment matters. We're going to see that there is strong evidence the environment matters as well. That'll be the subject of my next short video.